Hi, so this video serves to help you plot your data for your result summary that's due this weekend using example data for Veusz. So this Excel has our time in minutes, our max intensity which was found through the code, and then our zero, first order, and second order calculated y values. You'll calculate these using the equations found in your lab manual, and infinity is there to help because you need infinity to calculate out these values. So we have it in Excel so we can compare it, and also we need a CSV to plot in Veusz. So in Veusz, I already have it open. The first thing that we're going to do is import our data. So we'll find where it's located, and then import it, making sure that we have the right element set and the right delimiter. Now once it's in, we can go ahead and choose the scatter plot option. Here we're going to select our X and Y data. So our X data is going to be that time, and our Y data will start off with our zero order. Then we're going to play around with some of the formatting to make it more aesthetically pleasing. So I like to do open circles, and usually I like to use a red, but it might be nice to use a purple since our complex is purple for this experiment. Again, it's all up to your choice and what you think is aesthetically pleasing and makes the most sense for a figure. Once we have our colors, we can go ahead and play around with some other things. We're going to go ahead and change the marker size a little bit. Again, this is just up to your personal preference. And now we're going to go ahead and add in our axis labels. So the first one is going to be our absorbance, which is arbitrary units, and that is our y-axis. The next one's going to be our x-axis, and that is the time, and I have it in minutes. You can use minutes or seconds. And once we have those, we just want to make the formatting a bit better. So anytime you have numbers on your axis, you should have them the same format, meaning like the same amount of numbers in each. So here we use one of the format options in Veusz, and we'll do the same thing with the x-axis and then shift them over a little bit to make sure we have enough room for both the numbers and our label to fit in nicely. And once we have that, the next thing that we have to do is figure out the plotted line. So fitting a function allows us to put on any type of equation that we think will fit this data the best. Here we're going to use a linear equation in the form of a plus bx, where x is our x variable, and this is going to equal our y. We just need to tell it what our x and y data is, and then hit that fit function button. Well, I'll play around with some of the formatting, but what's really cool is in your console, it'll show you that equation. Only down part to this is it doesn't show us the r squared. It uses a different goodness of fit test known as chi-squared or reduced chi-squared. So we're going to report r squared by plotting it in Excel, and we're also going to put some labels on here so when we put in our key text it'll show that. And same thing with our line, we're just going to label this so when we put on other things it'll show up when we hit the key text. So now going back here, we're just going to plot this in Excel like you usually would. Insert a scatter plot or a line plot, and then going to trend line, and then we're going to display the equation and the r squared valued, and just compare the two just so you can see that the equation found in Veusz is the exact same equation that we found in Excel. So going back, if we look at our variables, we'll see that our a is close to the a that was found in Excel, and so is our b value. Although Veusz has it backwards than the way Excel reports it, so don't be alarmed, just know which one is your slope and which one is your y-intercept. And now we also have our r-square valued because Excel does provide that, and we're just going to add in a label that shows our r-squared. To put in your r-square valued, you'll go ahead and add in that label, and then we'll do r and caret. Ignore what I'm typing here, but we'll do r caret and then two brackets for 2 and then that's going to equal whatever that r square valued is. We'll then take that label and place that somewhere near the line. There we go. We can see we have a label, and we can drag this. You can also use the X and Y positions in that properties box that's shown up on views. You can change the color, you can change the font. Here I'm going to have it match up with my graph, again, because we want it to be very similar. And now we're going to add in the next file type. So this is going to be the same x-axis time, but now we're going to look at the first order plot. And we can see it added first order onto it. Similarly, we need to go ahead and fit a linear equation to this. But first we're going to change the color a little bit and make sure everything's consistent. So I'm going to increase the marker size to be the same thing, and then I'm going to go to the color and change it to be something that matches this color scheme a bit more. So still another type of purple. And here we're just adding in the key text labels. So again, once we add in our key, it'll be already set up. We go back to the fit a function, select our X and Y data, and then hit fit function, and once again in our console it'll pop up with our with our full function errors, and then in our parameters box we can see those numbers expanded a bit. Once again, we're just changing some of the colors to match our graph a little bit better. Now we're going to go back to Excel to make sure that these values match up and that we can get our r-square valued out. So we'll plot our time and our first order. Again, remember to figure out your first, 0, and second order graphs. We'll go ahead and use the equations in your lab manual. And here we go. We plotted the equation, we fit a line. We're going to display the equation in r squared, and then confirm our slope and y-intercept is the same in views and Excel, and they should be, and then put on that r squared value. So now that we're back, we're going to confirm that our slope and y-intercept are the same, and looking at it, they are the same. And we're just going to copy the label and change the colors and the numbers so it matches that of our first order graph. And then we'll align that better with our first order. Also, we want to keep things as close to where they should be as possible to not confuse the reader. And then lastly, we're going to do the second order. And here I'm just going to add in some labels to each element to keep my views file a little bit more organized. So same thing, we'll add a scatter plot. We'll go ahead and choose our X and Y data. And now we have our second order dots on there, and then we'll change some of the graph elements so it looks more aesthetically pleasing and more consistent. And once we get it to a point that we like, again, we're trying to stick on this like purple pinkish color scheme because of where it absorbs. You don't need to stick to this color scheme. You can choose whatever color scheme you think is best and works well with your data. And here you can see that there's a bunch of different fill options. Just go ahead and choose what you think is most effective at communicating your data. And then again, changing the marker size to be consistent. So now again, we want to go ahead and fit our equation to it after we move some things around to make it a little easier. So going back, we'll go ahead and choose the fit a function button, fit the equation. Make sure you choose your x and y variables. And again, we get a linear equation. We'll change the color so it matches our markers. We can already tell that this probably isn't the best fit for the second order. That probably tells us a little bit something about the reaction kinetics, or order of the reaction kinetics for this experiment. But again, this is sample data, so take this with a grain of salt. And just putting in some finishing touches here because I forgot to put in the key text. So now I'm going to put in the key using the button above to go ahead and put it up, and now we have everything labeled, maybe not in the nicest way, but you can play around with that. You can play around with the key length, how close things are to each other, swapping the marker, or the key text and the actual items on the key back and forth. You can change the fonts, all that fun stuff. So yeah, play around with these options until you find one that looks well and clearly can communicate the data to your audience. And then now we're just going to grab the last r² valued by plotting our time versus our second order. And similarly, we'll add a trend line and the r² valued. And we can compare our slope and y-intercept just to make sure that they're the same. And if we look at them, they are the same. So now we'll just go ahead and add in that label of our r² valued. And then change the color to match that line and move it closer to the line. And then the last thing is we need to compare these r² values, and whichever one shows the most linear relationship, so the highest r² valued or the one closest to 1, is indicative of the order of our reaction. Now once again, this is just sample data, so take this with a grain of salt. When you plot your own data, you'll plot it with all your first order equations on one graph, all your second order on one graph, and all your zero order. So what that would look like is your zero order for all 4 pHs on one graph, your first order for all 4 pHs on one graph, and your second order for all 4 pHs on another graph. This is just to show you how to plot all of them and give you a quick rundown before you do it. Excel will be a helpful tool, but it does not make pretty graphs. But yeah, that's all. If you have any questions, don't be afraid to reach out to your TA. And yeah, good luck with your results summary.